Are you someone who always answers a question thinking that the answer is correct, but when the results come out, you realize that answer was not correct and you lose marks? Maybe it happens to you in your PU exam, maybe it happens to your regular college exams. Then you are making some mistakes and you are falling for certain traps. So that's what I'm going to discuss. 5 questions that actually looks easy, the answer looks very easy, but after you select the answer and when you come back home, either you find out that the answer that you have marked is incorrect, or you actually when the results come out, you realize that the answer was not correct what you thought. Now you sometimes go to the teacher saying that, sir, why this is wrong, why this is not correct. So that before doing that, now from next time onwards, you will not going to do that mistake, because I am going to tell you some of the very common mistakes which 70% of the students actually are doing wrong. Not 1, not 2, 70%. So 7 out of 10 students are getting those answers wrong, and I am going to tell you what are all those traps, few examples, okay, 5 example questions through which we are going to explain why the questions that you are answering can be correct, right? So that is one important point. So if and now I like to welcome to you Diksha Karnataka YouTube channel, and if you have not yet subscribed to our channel, don't forget to subscribe. The button is there, right? And if you feel that this video is helpful for you, don't forget to give it a like, because that gives us the inspiration to go ahead and make more such videos for you only, right? Let us start. So first, what type of questions you should be very careful about? First of all, there is a question where it is mentioned more X means more Y. So suppose you said that I increase the mass, density will be more. So is it a correct statement or not? So these are the some traps that is very common in physics. Okay, so reflex reasoning, it is called reflex reasoning. So it blocks your mind, and you think that, okay, if I increase this quantity, the other quantity should also increase, right? But you should remember, for example, the example I gave you, that if you increase mass, it not necessarily increase the density. Density remains constant. Density for a given material at a given temperature is constant. So even if you increase the mass, volume increases, nothing else, but density remains same. So this is one very common trap that students fall for it. Okay, so more voltage, if you have a dielectric slab, if you insert a dielectric slab, what happens? Voltage increases, capacitance increases, what happens? So these are the common type of questions. Okay, now wrong quantity held at constant. Okay, so so you need to check a question whenever you are answering a question, that which are the quantities that is constant here. For example, in a circuit, if the battery is connected to the circuit, then voltage is constant. If the battery is not connected in the circuit, voltage is not constant. So if you need to read the question carefully, always I tell you that always read the question carefully and understand what are the quantities that is given in the question as constant. You will see that through an example, don't worry. Okay, next, formula before physics. You just read the question and start applying formula without realizing that what actually is being asked to solve. Okay, so for example, P is equal to V square by R, or K is equal to half mv square, before asking what actually is given or conserved or shared. Okay, so what are all the if the energy is being shared with another object, or it is being conserved or not. So those things you need to ask yourself and read the question, understand it. Okay, this quantity is conserved, that means it is a constant. So those things you need to understand just before reading the question. Okay, I need to solve it faster. So when you are trying to solve it faster, the problem that happens to you, you forget logical reasoning, you forget the understanding. That is one super duper important point. Next, so let's see one example question, and before I tell you the answer, try to answer the question, pause the video and answer the question before me. Okay, and tell the answer in the comment section below as well. Okay, a parallel plate capacitor is charged by a battery, and the battery is then disconnected. A dielectric slab of constant K is equal to 3 is inserted, filling the gap. Just a second. Filling the gap completely. The energy stored in the capacitor. So here we have a capacitor. which is basically charged using a battery, and then battery is disconnected. Now we have added a dielectric slab between the plates completely, which fills the gap completely. The dielectric constant is given, K is equal to 3. Now what will happen to the energy stored? Increases to 3 times, decreases to 1/3, remains unchanged, increases to 9 times. So what is your answer? Try to answer in the comment section below before I tell you the answer. So let's see. So what is the trap here? The trap is, you think that because if you insert a dielectric medium, the capacitance increases, so that means the energy should also increase, right? The trap is basically dielectric helps to store more energy. So if you have a dielectric medium, then the energy stored should increase. That means it should become 3 times. So that is the trap that 70% of the students actually answer it. Okay, but the correct answer is battery is no longer there. So battery is no longer there means voltage is not a constant. Only constant quantity here is the charge. So when you connect a battery to a capacitor, what happens? That the capacitor gains some charge. Okay, and when you disconnect the capacitor, only this charge remains same. The voltage is not constant. So half CV square, the formula that you are thinking that okay, the energy should be half CV square, C is increasing, so voltage should increase. This formula is not applicable here because voltage is not constant. So this formula is not applicable here. What formula you should use? You should use Q is equal to half Q square by C or Q square by 2C. Okay, so Q square by 2C, the formula that you need to use, and here charge is constant, capacitance is increasing. So what do you think? The energy stored in the capacitor should decrease, right? So it should be 1/3. Correct answer is the energy should be 1/3. Now for those who don't know what happens if you add a dielectric slab between the capacitor plate, what happens when you add a dielectric medium of capacitor, dielectric constant K, the new capacitance always increases. The capacitance always increases to K into C. Okay, so whenever you add a dielectric medium, capacitance, no matter whether it's connected to battery or not, this is the material present inside the capacitor. So that means capacitor always increases, capacitance always increases. Now what happens to the energy? Energy decreases because it is disconnected from the battery. Now the same question, if it is asked saying that the battery is still connected in the circuit, if the battery is still connected in the circuit, in that case, however, what happens? Voltage will remain constant. Then you can apply this concept and you can say that energy stored will also increase 3 times, right? So if battery is connected, answer is different. If battery is removed, the answer is different. So these things you need to be careful and little bit more attentive to. Okay, so remember, battery disconnected, charge constant, battery connected, voltage constant, right? Done. Let's move on with the next question. Two bulbs rated 60 watt 220 volt and 100 watt 220 volt are connected in series across a 220 volt supply. Which bulb glows brighter? Okay, A, the 100 watt bulb, B, the 60 watt bulb, both glows equally. Neither of them glows actually, means both of them are either fused or something like that. Now what your normal intuition says? So try to answer this question and mention option A, B or C or D. Okay, obviously D is not correct, so either option A or B or C. So out of this, which one you think correct? Mention in the chat, then I will show you the answer. So what is your mind is telling you that because 100 watt has a bigger wattage, it should have the brightest light, right? So 100 watt is the bigger rating, so it must be brighter. Obviously 100 watt light, if you add a 100 watt light, that glows much brighter than say a 50 watt bulb, right? So if you add 2 tube lights, for example, of say 60 watt each, that should give you 120 watt light, right? So better than one light. But here the catch is they are not connected in parallel, they are connected in series. So if you see that, series is written in bold to make you aware, even though in the exam this kind of things will not be there, so that will be much more trickier for you to identify. So this is series combination, whereas the normal combination that we use in our household are parallel combination. So in parallel combination, if you connect the battery in if you connect two bulbs in parallel, then no doubt 100 watt will be brighter. But here the combination is series combination. In series combination, you need to consider the resistance. In series combination, you don't need to consider the resistance of the respective bulbs. You need to remember that if voltage rating is same, if voltage rating for both of them are same, then whoever has lower watt has higher resistance. Okay, so you need to remember that resistance is given by V square by P. Okay, so now here V is constant for both the bulbs, 220. One of them have 100 watt, another one was 60. So 60 watt bulb has more resistance compared to the 100 watt bulb. So higher the resistance, it should glow brighter. Okay, the 60 watt bulb has higher resistance. If you calculate exactly, it will be 804 ohm. You don't need to calculate it, just need to understand that resistance is inversely proportional to the power. Okay, so if voltage is same voltage rating, if the voltage rating is same, then resistance is inversely proportional to power. Whoever has smaller power has higher resistance. Same current in series. Now when you connect the bulbs in series, what happens? When you connect the bulbs in series, okay, and this is a real KCET question, I just changed it a little bit, not the exact one, but yes, these questions did came in the KCET exam in the past, okay, with slight modification, but yes. So now if you see that in series combination, current is same. Okay, so what is the power dissipated by this one? Power dissipated by this one is I square R1, and this one is P2 equals to I square R2. So as you can see, the power dissipated or brightness depends on how much power it is actually dissipating. Its rating is 60 watt, but is it actually dissipating 60 watt? Actually no, it is dissipating less than that, but even in that case, this bulb is dissipating much more power compared to this one. So this one will be less brighter, the 60 watt one will be far more brighter. So this one will be brighter, this one will be less brighter. Okay, the brightness of 100 watt bulb will be less because they are connected in series combination, right? So that means power dissipated is larger for the 60 watt bulb. Now remember here, series combination compare resistances, parallel combination compare the power ratings or voltage. The voltage is constant. So whenever the series combination is given, you need to always compare the resistances of the individual bulbs, right? Now next question number 3. This is a ray optics question. Okay, some of you may not yet done the ray optics chapter, but many of you have already completed ray optics. Let's see if you are able to answer this question or not. The lower half of a convex lens is covered with an opaque black paper. The image of an object is formed by this lens will be. So we have a lens. Okay, half of the lens is covered with the black paper. It can also be asked that the half of the lens is cut. The lens is cut into 2 pieces. Okay, like this. This is also possible. Only the upper half of the image will be visible. Okay, only the lower half of the image will be visible. It will be complete image but dimmer. No image at all is formed, right? So what will happen if you cover half of the lens with the black paper? So it will basically, what do you think? Mention the answer in the comment below first before continuing. Okay, you need to remember that even if you cover half of the lens, or if you cut the lens into half, okay, the image will still be complete but it will be dimmer. Okay, so what is the trap here? The half the lens is blocked, so half the image will be lost. No, it is wrong. Okay, students, imagine that lens as a window not as a ray collector. Okay, so if you think that, okay, if I close the half of my eyes, I'll only see half of the object, is it happening? No, right? If I close one of my eye, can I see only half the image? No, I can still see the half the image. Yes, the extension reduces a little bit, the clarity reduces a little bit, but still we can see the object, right? So that is one important point. Okay, otherwise the shooters, they would not be able to shoot with one eye closed, right? That is one point. Now, so that means even if you cover the half lens, you need to remember every part of a lens receives rays from every point on the object and forms the full image. Fewer rays reach the screen, so the image is complete but less bright. Because what happens is that when you are considering a lens, this is an object, the ray is falling on each and every point on the lens. Okay, we do not show all the lights, all the rays, because obviously if you want to show all the rays, that will be impossible for us to draw. That's why you use 2 or 3 rays. But remember, all the light will fall on the lens. Now if you block half of it, these rays will still be there, they will still form the image, right? They will still form the image. The image will be less brighter because these rays are not allowed to go and meet here, so image will be slightly less brighter, but complete image will still be formed, right? Remember, covering part of the lens changes brightness, never the shape or size of the image. The same goes for if you break the lens into 2 parts or cut the lens into 2 parts. Okay, now next, another question. This is from mechanics. A bomb at rest explodes into 2 fragments of masses small m and 2m. Okay, the ratio of kinetic energy of the lighter fragment to that of the heavier fragment. So one bomb was there, it broke into 2 parts, one is mass m, another one is 2m. Now it says that what is the ratio of the kinetic energy of this one to this one. Okay, what is the ratio of their kinetic energies? 1:2, 2:1, 1:1, 1:4. Interesting question. Initially at rest means obviously initial energy was 0, so when they break up, what happens? Think about that and then answer. You must think that, okay, lighter mass may be moving faster or the heavier mass must be moving faster. So what happens there? What happens to the kinetic energy? Think again before answering. Think again before answering. Okay, most of you will answer that less mass, less energy, higher mass, higher energy, or in the other way also, higher mass may be higher energy, right? So straight kinetic energy formula, half mv square. Okay, half mv square reflects that, forgets everything. Now remember that momentum is conserved. First of all, when the object was at rest, okay, object was at rest, the total momentum was 0. So when they break apart, this one will have mv1, this one will have 2mv2. Okay, so momentum will be conserved. Okay, momentum will be conserved means kinetic energy can be written in terms of momentum. Kinetic energy is p square by 2m. This is the formula. Kinetic energy can be expressed as, what is kinetic energy? Half mv square. Okay, when the object was at rest, its momentum was 0. Now whenever it moved on to other parts, what happens to that object is that the momentum, suppose if plus mv1 in this side, m1 mv1, okay, this will be 2mv2 on the other side, 2mv2 on the other side, right? So here the momentum has to be conserved, so that if you add these two, final momentum should be 0 again. Okay, so momentum needs to be conserved. Now if you want to write the kinetic energy formula in terms of momentum, what will be the value? So let me write it like this, half m square v square. Sir, there was no m, extra m over here. Yes, I know. So that's why what we have done, I have divided with 1 extra m in the division. So it becomes p square by 2m. Okay, p is momentum, which is given by mv. For the lighter object, heavier object, for any object, this is a general common formula that you can use always. Kinetic energy is given by p square by 2m. Now, if mass is higher. If mass is higher, its kinetic energy will be less. If mass is smaller, its kinetic energy will be high. Okay, so if you just answer it without thinking, without reasoning, you need to remember, when a static object breaks into different pieces, main thing you need to consider is here the momentum, which is conserved. Okay, so kinetic energy is inversely proportional to mass. That means higher the mass, smaller is the kinetic energy, and smaller the mass, higher is the kinetic energy. So it will be, the answer will be option B, that is 2:1. Now, question number 5, last question. In a photoelectric experiment, the frequency of light above threshold is kept fixed and its intensity is doubled. The stopping potential. Now, this is a question from dual nature of radiation and matter. Some of you may not have yet done it, so I do not expect you to answer it, but if you want, just guess the answer. Now, remember, we are doing a pattern question, right? Pattern, some pattern is there, so you might think that, okay, this appears to be correct, so I should go and answer the opposite one, right? So that is one tendency that students do, but that is also not correct. You should understand the question and answer it properly, then only you will be able to master physics, right? Do not always think that teachers always give you the answer which is opposite, right? It is also not true. In this pattern, yes, but generally it is not. Okay, now the trap here is, the more light means more energy, so the stopping voltage must rise, right? Intensity is confused with photon energy. Intensity and photon energy are two different things. Okay, so if you look into the Einstein's equation, EV naught equals to h nu minus phi naught, depends only on the frequency. Doubling the intensity does not change the stopping frequency. Okay, stopping voltage does not change. That means so the kinetic energy of the emitted electron remains same. Okay, stopping potential remains same. Stopping potential remains same because it is independent of the intensity. Okay, it depends only on the frequency of light. The stopping potential depends only on the frequency of the light. The kinetic energy of the electron emitted in photoelectric effect depends only on the frequency of light. It is independent of the intensity. Intensity means if you increase the intensity, more number of electrons will come out. So you will get a higher amount of current. Current is dependent on intensity, but the stopping potential, stopping frequency, that does not depend on the intensity of light. Okay, so frequency controls kinetic energy and V naught. Intensity controls only the number of electron, which is basically current. Okay, so intensity controls current and frequency controls the kinetic energy and the stopping potential. Okay, so now this is a summary of whatever we have learned. So don't go anywhere, we are not yet done. Let's look into the summary. Okay, first what you need to do is that which quantity is fixed over here. Okay, so whenever you are reading a question, you need to ask yourself, is there a quantity which is fixed, whether is there charge or voltage, frequency or intensity. The condition in the question decides whether which formula or which concept you need to use. So based on question to question, based on the question which is given to you as constant, you basically need to figure out, okay, this is constant, so I need to use the other formula where this is given as constant. Okay, or we cannot use this formula because this is not constant. Right, for half CV square is not applicable because V is not constant, but half Q square by C is applicable because here Q is constant, only C is changing. That is one important thing. Okay, now question 2 to 4, what is shared, then apply the formula. Let's check that whether they are in series, they are in parallel. Okay, momentum is constant or not. Based on that, you need to apply the formula. And question number 3, okay, picture the physics object. Okay, lens is a collector of light. Okay, not a window. So even if you close the half of the lens, it will still be complete image, it will not be half image. So these are the very basic logical questions that you need to figure out and answer. Okay, Now if you want to practice, there are few questions that is built on the same trap. Let's see one by one. I will not solve them, you need to answer them in the chat section below. Let's see the same capacitor in as in question 1. So question 1, whatever capacitor is given, okay, but the battery stays connected while K is equal to 3 dielectric is inserted. So capacitance C, okay, that is there, but now what you have done, you have inserted the battery is still there and you have inserted the dielectric medium. What happens in that case? Now try to answer this question. Okay, I'm not sure answer is given. No, answer is not given, so try to answer it. Next question, the 60 watt and 100 watt bulbs, both rated 220 volt, are now connected in parallel. Now what happens? Which glows brighter? Try to answer it in the chat below. Okay, next question, a convex lens n is equal to 1.5 is fully immersed into liquid of refractive index 1.5. the lens now behave as. So here it is a glass lens, the refractive index is 1.5, the liquid's refractive index is also 1.5. Now what happens? Try to answer this question. Will it behave like a converging lens? Converging lens is basically convex lens. Okay, converging, if you are confusing, common term, we call it convex. Common term, okay, in air it is basically equivalent to convex lens. Diverging is concave lens. A plain glass plate, a concave mirror. So try to answer this question and mention the question number 3 option is this. Okay, a bullet of mass m is fired from a gun of mass capital M. Capital M is greater than small m. Immediately after the firing, the kinetic energy is greater for the bullet, greater for the gun, equal for both, depends on the charge used. Okay, depend on the charge means the gunpowder used. Okay, so I know which one is obviously wrong, but what are the other 2 options that you think which of them is correct? In a photoelectric setup, the frequency of incident light above threshold is doubled. The maximum kinetic energy of the photoelectrons. Here, frequency of the light is doubled. Then what happens to the kinetic energy of the photoelectron? Okay, exactly doubles, more than doubles, less than doubles, stays the same. Next, a stone is thrown vertically upward at its highest point. V is equal to 0 and acceleration is equal to 0. V is equal to 0 and acceleration is equal to g downward. V is equal to 0 and acceleration is equal to g upward. V not equals to 0 but acceleration equals to 0. Which one is correct in this case? Question number 7. A charged capacitor is disconnected from its battery and the plate separation is doubled. The potential difference between the plates, what happens to the potential difference? Doubles, becomes half, remains the same, becomes 0. 2 projectiles are launched with the same speed at 30 degrees and 60 degrees to the horizontal. Their horizontal ranges are greater than 30, greater than 60, equal, cannot be compared. This is a very interesting question based on one very simple fact. Check these 2 angles. They are very special angles. Okay, they are very special angles. Again, try to answer them and mention the answer in the comment section below. Okay, so this is the answer key for those who want to check the answer. Okay, so just a glimpse, check if you have answered them correctly or not. Okay, next, read the condition before the formula. That is the if you want to be in the top 30 bracket where students are doing it correctly, if you want to be in that bracket, you need only one habit, that is read the condition before the formula. Read the question, read the condition, what is constant, what is variable. These things are important. Okay, every trap in this deck hides in one word: disconnected, series, half, at rest, intensity. So these are the things that you need to understand, right? So if it is said disconnected, connected, half, full length, so those things you need to understand what is the quantity which is constant. Okay, based on that you need to decide which one you need to, which formula or which concept you need to apply, because in many cases and these kind of questions are very common when multiple formulas are there for one single quantity. That's for example power. Okay, power, energy stored in a capacitor, same concept but different formulas are there, right? Half CV square, half Q into V, half Q square by C, 2C, half Q square by C. Okay, so these are the formulas. So based on what concept is given in the question, you need to apply what formula you need to use. So that's what very important. Do not stick to one single formula. Understand what is constant, and based on that you choose the relevant formula, right? So I hope that this video helps you a lot, and obviously give it a like as if you have liked it. Also I expect all of you to answer the questions in the comment section, right? I'll be back with a more such tips and tricks in future. Till then, bye.